Hi, and welcome to probability distributions, and this would be day 4 of the unit. Alright, so we're going to kind of pick up where we left off in class the other day. So for example 1, a box contains a large number of carnations, which 1/4 are red, the rest are white. Carnations are picked at random from the box. How many flowers must be picked so that the probability that there is at least one red carnation among them is greater than 0.95. Alright, so our notation is going to be x, such as a binomial distribution, and n, we don't know how many there are, but we do know the probability to be 0.25. Because 1/4 are red, therefore the probability is 0.25. And we want the probability of x. It says at least 1. At least means greater than or equal to 1. So it's 1 minus the probability of x equaling 0. And in that case, it would be 1 minus 0.75 to the n. We get that because the probability of getting the red is 0.25. Probability of not getting a red is 0.75. Alright, so now this has to be greater than 95. Sorry about that. Or 0.95. So 1 minus 0.75 to the n has to be greater than 0.95, because that's what the probability states. So I'm actually going to add 0.75 to the end of both sides and subtract 0.95. So I would get 0.5 is, or 0.05, excuse me, is greater than 0.75 to the n. Now I'm not sure if you remember, but when n is in the exponent, I actually need to take the log of both sides. So I have the log of 0.05 is greater than the log of 0.75 to the n. Then bring the n out in the front. Divide by the log of 0.75. So the log of 0.05 over the log of 0.75 is greater than n. And when I solve, let's see. Let's see here. When I solve, I will have 10.4 is greater than n. Okay, sorry about that. The log of 0.75 is a negative number, so and so is the log of 0.05. So since we divided by a negative number, we actually need to go in here and change our inequality. So we will have 10.4 is less than n, and then to put it back to the way we like to read it, is 10 has to be greater than, or sorry, n has to be greater than 10.4. Since n has to be greater than 10.4, n must be the least value of n must be 11. So they must pick at least 11 carnations out of the box to make sure that there is at least one carnation among them and that it's greater than 0.95% or 0.95. So n must be 11 here. Okay, then we have expectation of a binomial distribution. Really, it's just saying that we're going to take n times the probability to find out the expected value. So a biased dice is thrown 30 times and the number of sixes seen is 8. The dice is thrown a further 12 times. Find the expected number of sixes for these 12 throws. So P is equal to 8 out of 30, which is 4 out of 15. So that's the probability it's going to happen. N is 12. So I'm literally going to take 12 times 4/15 and multiply. And let's see here. 3 goes in here 5 times, 3 goes in here 4 times. So I have 16 over 5, which is 3 with a remainder of 1, so it's 1/5, so it's 0.2. So the number of sixes you could expect in 12 throws would be 3.2. On the next page, on the back, we have the variance of a binomial distribution. Well, we talked about variance before, and we said that variance is the measure of dispersion. And you're given this definition here on the formula sheet. So the variance is just equal to n, the number of trials, times p times q, where q is the p minus 1 or the failure, the success. So for the binomial distribution, we have an expectation, which is n times p, and a variance of n times p times q. And if we know the variance, we can find the standard deviation because the standard deviation is simply the square root of the variance. So let's just add this. The standard deviation is equal to the square root of the variance. Alright, so let's try a problem. In a large company, 40% of the workers travel to work on public transit. A random sample of 15 workers is selected. Find the expected number of workers in the sample to travel to work on public transportation and the standard deviation. Well, we'd have to find the expected value. So my workers, and they're binomial distributed. We have 15 trials, and the probability is 0.4. So my expectation is going to just simply be 15 times 0.4. Which is 6. And the variance of W is literally N, which is 15, times P, which is 0.4, times Q, which is 1 minus P, which is 0.6. And in this case, when I multiply those all out, I would get 3.6 for my variance. Well, my standard deviation is simply the square root of 3.6. And when I do that on a calculator to 3 sig figs, it'd be 1.96. 0 just by taking the square root and rounding. And that's really all there is. All right, until next time.